This important lesson is looking at the idea of relative, absolute, and mixed cell addressing. This is one of the most important concepts in Excel. If you get this one figured out, Excel will make a lot of sense. If you don't, you'll always struggle with a basic concept. So let's take a look at the idea of relative cell addressing. Right here I've got a simple subtraction problem. 45 minus 65 is equal to. Now, one thing that I could do is pull out my calculator or do this in my head and say, well, that comes out to minus 20. And so I put in the number minus 20, and that's right. The problem with that is that I would have to do that with every one of these numbers down here. Pull out my calculator or figure it out in my head and type it in. Instead, we're going to use a formula. Now, a formula in Excel always starts with an equal sign. So let's type an equal. And then instead of typing in the number 45, I'm going to use a cell reference. That is, where does the number 45 actually appear? Well, it appears over here in cell A10. The best way that I can reference that particular number is just click on it. So equals A10. Alternatively, I could type in equals A10. Then I put in a minus sign, and then I click on the 65 or type in C10. And then finally, I push enter. And what I get is the number minus 20. Now, here's where the strength of Excel really comes into being. If I want to copy this formula down, what I do is I click on the cell, and you'll notice that there's a fat plus sign. If I move my cell pointer to the bottom right of that yellow cell, you notice that there's a little box there. When I'm right over top of the box, it turns into a black plus sign. And now I can click with my left mouse button and drag it down right to the bottom of the list. I can also just double click and it will do the same thing. Now this is great because the minus 20 changes to a 5, which is 20 minus 15. And then another 5, and then a minus 20, and it's 65, and so on. So all of these numbers are correct. But how does that work? Well, the trick in Excel is that it uses something called relative cell addressing. Now what I mean by this is, well, let me explain it this way. Excel actually operates on 3 levels. So the first level is what you see as an answer. So the answer to the formula, which is A10 minus C20, is minus 20. So this is what you actually see in the cell. So that's the first level. The second level is what was the formula that actually gave us that. So A10 minus C10. By the way, I put a little apostrophe in front of it, which will disappear, but that makes it into text so that it won't actually show the number minus 20. That's just an aside. But here's the important thing, the third level. And the third level is what is the interpretation or the meaning of that particular formula, A10 minus C10. And this is where relative cell addressing comes in. Let's take the cursor over here to E10. So I've selected cell E10. Now the question is, where is the 45 from here in terms of rows and columns? Well, the 45 is 4 columns to the left in the same row, and then the 65 is 2 columns to the left, same row. So this particular formula, when we copy it down, what we're actually copying down is the rule behind it, or the interpretation of that particular formula. Let me unhide a column here and I'll show you what I've typed. There we go. So the actual rule is take the value, which is 4 columns to the left, 1, 2, 3, 4, and the same row, and subtract from it the value which is 2 columns to the left and the same row. And that's why we get minus 20. Now the nice thing about that is that that works all the way down. So let's go down to the very bottom and read it out. Take the value which is 4 columns to the left, which in this case would be 10, in A16, minus the value which is 2 columns to the left, which is C16, and the same row. So you're copying not the formula, but actually the interpretation or the rule behind the formula. And that's how relative cell addressing works. Okay, let's go to the next tab. Down here I've got one called absolute. And we're going to put in a formula here, which is 1 divided by 8. Now instead of putting in 0.125, which is what our calculator would give us, we're going to put in equals A12, which is where we find the 1, divided by, which is a slash, and then the 8, which is in B9. So A12 divided by B9. And then I push enter. Now what I'm going to do is I'm going to copy this down. So I'm going to go to the corner of the yellow cell. I said that you can just double click and it'll copy it all the way down. Oh, what happened? Well, here's the problem, is that relative cell addressing says, let me unhide this. Here's the rule. So take a look at this first formula again here. Take the value which is 1 column to the left, same row. So that's where we found the 1 from. And divide it by the value which is 3 rows up and the same column. So that's the rule that you're copying down. Well, the reason why we get a divided by 0 error is we'd be taking the number 2 dividing by a blank, which has a numerical value of 0. Over here, we take 3 divided by 3 rows up, the word decimal. 3 divided by decimal gives us a value here. This one looks like it works, but it's the wrong answer. 4 divided by 1, 2, 3 up is 4 divided by an eighth, which is 32. Well, that's the wrong answer. We actually want that to be 0.5, 4 divided by 8. So this is where we need to employ something called absolute cell addressing. Absolute cell addressing is where you add dollar signs in front of the letter and in front of the number. And that fixes the position of the 8, where we're always going back to. So let me go up here to the formula bar and just click in front of the B, and I'm going to put in a dollar sign. And then I'm going to arrow over and put in a dollar sign there. By the way, if you press your F4 key, it will scroll through all possible combinations of dollar signs. That's just an aside and a hint that'll make your life a little bit easier. But I'm just going to manually put them in. Now, by putting a dollar sign in front of the B and the 9, it changes the rule over here. Notice I didn't put the dollar sign in front of the A12, so it's allowed to change relatively. So take the value in the cell which is 1 column to the left and the same row, and divide it by the value which is in cell, well, let's do it this way, in row 9, because we put a dollar sign in front of the 9, and column B. So putting a dollar sign in front of the 9 and putting it in front of the B changes the rule to look like this. Now watch what happens when we copy this down. Everything looks great. Let's go to the very bottom here and see if the rule works. Take the value in the cell which is 1 column to the left, which is a 10, and divide it by the value in the cell which is in row 9 and column B. So in other words, by this 8 in B9. So 10 divided by 8 gives you 1.25. So that's a really important thing in stats. It's called absolute cell addressing. If in business, say, you've got, say, a finance sheet, and you've got a little table of constants in there, and so you're always going back and grabbing the GST value, for instance, and multiplying it, then that's where you would reference that particular cell. There's one more thing I want to show you, and that is mixed cell addressing. And mixed cell addressing is where we put a $sign in front of the letter or the number, but not both. So let me show you how to do a multiplication table here using mixed cell addressing. Okay, I'm going to start this by multiplying 10 by 5 to give us 50. So let's put in an equal sign to start the formula. Equals, and then I'll click on A11. That's my 10. To do a multiplication in Excel, you use the star or the asterisk above the 8. So star, and then the 5, which is in B10. And of course I get 50. Now I should be able to copy that down and then across. And the problem is that the numbers get bigger and bigger and bigger as we go until eventually you end up with an error here. All right, what's happening here? Well, let's unhide the rule and see what our original formula said. So going back here to cell B11, where I first put in the formula, it said take the value which is one column to the left in the same row. So that's where we got the 10 from. And multiply it by the value which is one row up, same column. That's the 5. So it works for the first cell. By the time we get down to here, we're actually multiplying 750 by 500. And it gets bigger and bigger and bigger until by the time we get down here, it actually, well, it just craps out on us, right? Because we're multiplying 1 times 10 to the 129th power times, in scientific notation, 1.3 times 10 to the 213th power. So that doesn't work. So how can we fix that? Well, what we do is we go here and we say, what column and what row are we always going back to grab numbers from? Well, we're always going back to these numbers, which are in column A. And we're always going back to these numbers, which are in row 10. So in our formula, we're going to put $signs in front of the A and in front of the 10, but not in front of the 11 and the B, because it's only column A and row 10 that we're going back to get the numbers. Now watch what happens. I'm going to pull this down to copy it, and then I'm going to pull across, and that is perfect. Let's take a look at this very last number. $A17 times $10. And so this changes to take the value in the cell, which is one column to the left. Whoops, no, we're going to say which is, got to get your fingers on the right keys, which is in column A, and the same row, and multiply it by the value which is one row up, and let's try that again, which is in row 10. There we go, and the same column. Let's take a look at that formula and compare that to what's written over here. So $A17 times $10. Take the value which is in column A and the same row and multiply it by the value which is in row 10, and the same column. So that is how mixed cell addressing works. And this ends the lesson.